You are now listening to the Add 10 Gallons Concrete Podcast.
Wait, the answer was add 10 gallons?
Add 10 gallons.
My first thought was we got to put Acti-Gel in it.
Yeah, great.
Truck's on the way. On the way.
Yeah, okay. I've got two observations, neither of which are really educated or well thought out. Which are like most of my observations are.
There aren't a lot of problems on a job site that can't be solved with a sack full of biscuits.
Today's episode of the Add 10 Gallons Concrete Podcast is brought to you by Acti-Gel 208. Acti-Gel 208 is a high-performance additive for the concrete industry that is greatly beneficial to the producer. It enables them to increase the percentage of manufactured sand by up to 100% and completely replace all the natural sand in the mix. In areas where natural sand is scarce, inconsistent, and expensive, this provides a huge benefit to any ready-mix company out there. Benefits of manufactured sand and concrete include consistent air content, improved compaction, and increased density. Now, in the past, the downside of using manufactured sands was that they were hard to pump, hard to place, and hard to finish. Well, Acti-Gel 208 solves all those issues. By improving suspension, stability, and the quality of the cement paste in the mix, Acti-Gel overcomes the old issues with manufactured sand and leaves them behind. Let Acti-Gel 208 improve the quality of your mix while saving money on every yard you produce. For more information, visit us at actigel.com. That's ACTI-GEL.com.
And with that, we welcome you into the next installment of the Add 10 Gallons Concrete Podcast. We might not be number one, but I bet the Tennessee Volunteers are here shortly. Joey Bell, what you got to say about yourself?
Oh, it's the best weather we've had in probably 15 or 16 years. High around 52, low around 49. Feels like 98, though.
I wonder where he was going with that.
That's pretty inside joke, way inside. If you didn't watch the Tennessee-Alabama game, the final score was 52-49, Tennessee's way, in case you've been living under a rock.
Paul, have you been living under a rock?
I don't want to play this game anymore.
Paul gets to see how the other half lives now.
He might as well have been under a rock during that game because he was out of the country with little to no internet service.
Yeah, can't get into where we were, what we were doing, but yeah, I was in a foreign country on an island with literally no cell phone service, and I would get Wi-Fi, and it was horrible Wi-Fi, so it was spotty, and you couldn't see football when you were over there. I was over there for a while, and of course, it happened to be the third Saturday in October, and so my brother is messaging me, because iMessage would work when you had Wi-Fi, or WhatsApp would work when you had Wi-Fi. And so he's messaged me like play-by-play of the game, and it was just awful, absolutely awful. My stomach was turning. I was actually in a mess hall, and our coworker was like, I really hope Alabama wins because I don't think I can handle you the rest of the day if this goes the wrong way. And so I'm reading iMessage. I got the three dots. They're like, oh, they left us too much time. We got Bryce Young. He goes right down the field. We get a chance to kick a game-winning field goal with a future NFL kicker. And what does he do? Missed. Unbelievable. And they somehow go the other half of the field in 5 seconds and make a field goal. Absolutely awful. Congratulations to Tennessee, to Joey. People coming out of the woodwork to text me like I wasn't aware of what was going on and needed to hear from everyone and all their horrible opinions, but whatever.
Well, if it makes you feel any better, to show the respect that I have for you, I didn't reach out to you. Well, I think I sent a text out to you and Josh that night, and I basically just said, Paul, we'll talk next week. And so out of respect for you, I didn't, kick you when you were down and could barely defend yourself with no internet, but instead I waited until we got on this internationally broadcasted radio program to talk trash. But in all seriousness, I'm still so jaded as a person with battered Vol syndrome that the reality of going 8-4 for me is still real.
Well, it's like everybody listens to us. Hopefully, y'all watch SEC Shorts, the YouTube channel. It's fantastic. Like the last 4 episodes are all about Tennessee as the central character, and you notice Hope has not entered any of those videos.
She's on the way. I would venture after this weekend, she either makes an appearance in a positive or a very negative direction of Tennessee.
Yeah, either way, right?
What happened the week of the Tennessee-Alabama game? They had this whole list of things you couldn't, or things that people weren't able to do the last time Tennessee beat Alabama. It was like they couldn't tweet about it. They couldn't, I forget. There's a whole list of stuff. And just thinking back, it legit, it was 15 years. 2006 was the last time we beat Alabama. And to, go down that list and think of all the things that weren't there, it doesn't seem that long ago, but it was unreal to see all that stuff that wasn't around back then.
Yeah, the iPhone didn't exist. I mean, forget iPads and stuff. The iPhone did not exist last time Tennessee beat Alabama. Speaking of things that do get updated in the concrete world, I got one for you. So, in the state of Montana, the building code there has been revised so that 3D printed walls are given equal viability as compared to concrete block walls.
In their book of standards.
The building code. The building code in Montana recognizes 3D printed concrete can be a substitute in place of block walls for homes. Like the first floor of a home made out of block walls can now be 3D printed concrete.
That's awesome. So you predict that it's going to happen on a state-by-state basis, and it doesn't necessarily, that adoption doesn't have to necessarily be driven by the ASTM or ACI or any type of industry. It could just happen by individual state DOT departments or just states in general.
Yes, an aspect of this we've never talked about.
Yeah.
Is we're always concerned that the industry is not going to adopt it. And when we talk about regulation, we're thinking about policies and programs that run through ACI and RMCA and all these places, but we haven't really talked about here about approvals from the states. Mm-hmm. And so in this case, Montana's the first state to come out and be like, you know what, if you want to 3D print these retaining walls or basement walls, have at it. And check out this 3D printer. This Joker's on tracks. I like this one. This isn't like a 3D printer that's on a truss system. This one's like a robot printer that...
So for the listeners here, we'll cut this up into a YouTube clip and put it on put it on Instagram and LinkedIn as well. But if you're driving right now, essentially this 3D printer, it's a single arm, 3-axis machine. So it goes forward, backwards, up, down, side to side. But it's not stationary. It's actually on a set of tracks that you would see on a tank or an excavator or something.
It does look like a tank, like the way the base is built.
And then on each side, on all 4 corners, the front and back of each tank track, there's actual pneumatic stabilization leveler pads, kind of like you would see in like an auto leveling system on an RV or something like that. So I guess it moves, becomes stationary, does its job, then can move infinitely to build as big of a structure as you want. That's awesome.
Yeah, it's pretty sweet, right?
Joey and I just got back from ACI in Dallas, and we were actually in a committee meeting for 3D printing. And, while states like Montana are looking to adopt this kind of technology, not to talk out of school or throw anybody under the bus, but you know how slow those committee meetings can move sometimes. And they were talking about what to call it. Do we call this 3D printing ink, 3D printing concrete, mortar?
A medium. Like a cementitious medium. There's all kinds of terms thrown out there. There was a debate on whether it was mortar versus concrete, because in a lot of this conventional 3D quote-unquote concrete, I guess we can start saying now, there's not any or very little coarse aggregate that I've seen in there. So they are essentially placing mortar, just sand, cement, and water, of course, whatever additives. But if there's no coarse aggregate in there, then the definition of concrete, if you go by that, then that's not concrete, that's mortar.
Yeah, and it's the Wild West right now. I mean, we're not going to get too far into mixed design and things of that nature because, honestly, we don't have the expertise. But I'm really everyone's kind of working towards gaining that expertise right now. And, I mean, you can look at fibers, small aggregate, and even like what we've talked about on this podcast many times, you could put about anything in concrete. So I'm sure people are looking at ground glass and different kind of pozzolans and stuff like that. But, I mean, to your point earlier, it's not necessarily the traditional concrete that you would think of coming out of the back of a ready-mix truck.
Right. We'll have a future guest on here, not this episode, but the next episode, and we'll talk about what they're doing is a little bit different, and they're solving one of the problems that we see. And if you don't have reinforcement in these walls, I just don't see how you're like. Look, we love fiber. Some of our best friends work in the fiber business. Big, giant fans of fiber, but that doesn't help with the shear stresses that these walls are experiencing. You've got to be able to provide that reinforcement. It's a huge challenge for these 3D printed mortar guys right now as they try to make these advancements. There's a post that Seth Tandick from Concrete Logic podcast tagged me in on LinkedIn, and it's something they don't like to show on these 3D printed structures is how easy it is to have settlement cracking. And these are massive cracks, like 1 millimeter or larger separations going through many, many, many layers all the way down, because the consistency you need when printing these layers is so difficult to achieve. It's difficult for us as ready-mix guys to make consistent batches of concrete. Well, what if the consistency of every batch is almost not, like the tolerances are so tight because it's 3D printing method, and then the ability to make adjustments on the fly is not very easy because it's a continuous process rather than a batch process. So a batch shows up and it's a little too wet, you can dry it up. Or if it's a little too dry, you can wet it up. But if it's a continuous process, then you're doing your very best to make it right in that moment be the exact water cement ratio you need, and then pump it through the line and hope you don't run into any problems. Because as you're printing around, if one section is a little drier or one section is a little wetter, your sub base isn't exactly right, boom, you got massive issues. Man, it's going to be tough. It's exciting, but these are the challenges that we're all going to have to think of and think about how we're going to overcome them if we want to see this be successful. And we do. We like technology. We think technology is awesome. So we want to see these guys be successful. So if you start coming across this stuff, what we're trying to do here, or at least I am, I don't want to speak for these guys, but what I'm trying to do is think about these things and then offer solutions. And right now, I don't have a solution for that, so it just sounds like I'm complaining into the ether.
Yeah, no, but there's plenty of people out there working on the solutions, that's for sure. And we've had a few on the program, and we'll continue to have guys from that industry come on and talk about it, because it's definitely something we're keeping an eye on.
Yeah, so I'm excited to see what the future of that is. I was going to ask Joey what he wanted to talk about, but all he wants to talk about is Alabama versus Tennessee, and I'm tired of talking about that. So, Josh, what do you have?
Yeah, well, since we're a couple of weeks removed from that, Joey's got the right to take like a couple of weeks to come down from that high.
I don't know. People probably thought we weren't doing this show so that I could avoid talking about
You're probably right.
Tennessee game.
You're probably right. No, I stumbled across something interesting just perusing the internet, and talk about advancements and adjustments that you have to make on job sites for these 3D printers and stuff like that. As advanced as that is, imagine having to tackle the age-old problem of rats.
Like mice, right. Like giant mice, rat?
Well, this is particular to New York City, so we're talking big, giant cat-sized rats. And So let me read you the headline and then I'll go in on it, all right? So NYC law targets construction sites as part of a new rat abatement program. Essentially, a new set of laws will go into effect next year, the beginning of next year, Q1, that will aim to curb one of New York City's most notorious problems. Essentially, the Rat Action Plan will put in legislation that will require construction contractors to pay for an exterminator on hand. Like they'll have to have a third-party exterminator at the job site when they're doing any kind of excavation.
Is this already been passed?
Yes, it goes into effect Q1 of next year.
Wow. So the city couldn't solve the rat crisis. So now they're forcing private companies
Yes.
to try and solve it for them.
Yep. Where the proposed construction work involves 50% of more of the floor area of a building. And then what else? Where the proposed vertical or horizontal enlargement increases the amount of building floor area by more than 25%. So if you're expanding the floor by more than 25%, or if you're working on more than 50% of the floor of an existing building, and then obviously on all new construction where you're running excavation, you have to have a third-party like exterminator service on site to mitigate any rat infestation issues.
This makes me so mad.
Right.
Do you guys remember what was that Liam Neeson movie from several years ago, like The Gray or something, where he's like plane crashes and he's like alone in the wilderness, or he's got a couple guys with him in the wilderness. Anyway, what made me think of that is in that movie at the beginning, Liam Neeson's job is up in like Alaska or like way in northern Canada, and he works with this pipeline crew or some kind of oil crew or whatever. His job is to shoot wolves like during the work hours. He's like sits up there on top of this hill and he shoots wolves, to kind of keep them away from the crews there. So are they going to have some guy from Brooklyn with a 22 with rat shot doing the same thing, keeping rats away from the crews
Well,
there?
seeing as it's New York City, he probably won't be carrying a firearm. It'll probably be some poor old boy from Orkin with some pellets.
That sounds like some union stuff too, like some union guy cooked that position up.
Well, hey, before we go down that rabbit hole, because I'm not in the mood for a rant today, there is a list that came along with this article, and you guys might find it exciting to know that New York City actually isn't number one in rat infestation issues. You want to guess who the number one? All right, so the number one ranked metropolitan region by a number of rodent treatment platforms that were performed. I guess when you call and schedule for like an exterminator for like rodent extraction or whatever you want to call it, they categorize that and log it. So the metropolitan area with the most, I guess, calls to get rid of rat issues. You guys want to take a stab on what the city is?
Baltimore, Washington.
Can you give me the state that it's in?
No, that'd be way too obvious.
Then I'll just say San Francisco, since he said D.C., which is what I would have guessed.
Oh, you guys are close. So Chicago is number one.
Chicago, incredible. Well,
Right.
Hold on a second. I don't like the measuring metric that you used. Like
DC is 4, San Francisco's 5. So you guys are neck and neck.
But I don't like that measurement, like how many calls. That's like, you can have all the rats in the world, but if you don't like call somebody about it, then you're just like living with it. I heard that there are as many rats in New York City as there are people, and that or more than that, and like the biomass of rats is like equal to that of people in the city of New York.
Oh, I'd subscribe to that theory. That wouldn't surprise me.
But that's crazy.
I remember Baltimore having so many rats. And I remember when I lived up there, every now and then I'd get off work and I'd go sit on the back porch and smoke a cigar and drink a glass of bourbon. And I'd watch them rats run up and down the alleyway till dark. And them was big suckers too. Like you were talking about big as a house cat. They were legit as big as a cat. Most populated area that had rats I've ever seen.
Yeah. I'm not going to name names here, but there's a certain individual that works for the same company that we do. And when he was living in that area of town, close to Joey Bell, him and his buddies that lived in the alleyway, they would have a competition to see who could kill the biggest one. They would go week by week. They'd shoot them with pellet guns.
I remember that. I thought it was like they set a quote unquote season for it. Like I don't know if it was a month or however long. And at the end of this season, like however many were in the house, let's say there were 4 people in the house. If whoever killed the biggest rat, like the other 3 had to pitch in and get it mounted. Is that right?
Yes. Yeah, I forgot about that part, but you are correct.
Man, y'all got some weird friends.
Hey, Baltimore is number 7 on this list, by the way, so they got plenty to shoot at.
Is Philadelphia on the list?
They are number 6.
Number 6. Yeah. I live outside of Philly, technically. To me, I feel like I live in a city. Everybody that lives where I live, they're like, this is not a city. I'm like, well, there's row homes and high rises. I don't know what you call this, but whatever. There's not really a lot of rats around where I'm at, but I've seen some places in Philadelphia that look like they would have lots of them.
And really on this list, if I read you the top 10, there's really only one that would pop out and be kind of like surprising, and that's Denver at number 10. So like we're going, all right, from first to 10th, we got Chicago, New York, LA, DC, San Francisco, Philly, Baltimore, Cleveland, Detroit, and Denver. So out of all that, I'm like, oh well, Denver's trying a little hard to get in that top 10.
They just want to get noticed.
Yeah, the other 9 make sense.
The other 9. Well, golly, I'm just thinking back to the fact that the government who's in charge of taking care of the city is like, you know what, we're going to make private industry take care of the city for us because we're doing such a horrible job of it. It makes me so mad. Beyond just being angry, I'm just laughing to myself because when you're running a business and you're pricing in all of your costs into your projects so that you can make sure that you're covering that and still make a profit, like how are you going to like pencil in like rat exterminator into your costs? Like, oh yeah, don't forget, Mr. Accounting and Finance guy.
Yeah.
We need to how many rat hours per project or per cubic yard or square foot? Like, how are you gonna divide that up? Get it out of here.
Yeah, man. Yeah. So, figured you guys would find that mildly entertaining. And then on top of all that, like another dumb problem. Same grouping of articles that I was reading. The headline reads, "Top reasons workers don't use PPE properly."
Oh gosh.
I immediately scoffed.
Please continue.
Yeah, so,
Parody. We do not endorse. How many times have we said that on this show? We do not endorse what these people are saying.
yeah. But yeah, so this is according to a new survey. What survey? I'm not 100%. Oh, by PPE provider J.J. Keller's SafeGear. So SafeGear. I may trust that survey. I'm not sure.
I mean, who else is going to do the survey?
Employers.
Nerds.
If it was an employer survey, I probably wouldn't.
Actually, probably wouldn't. Yeah, you know they're going to lie.
They're going to fudge a little bit. Yeah, I wear my hard hat 99% of the time. Yeah. Well, I mean, I guess if it's just the provider, they're a little bit more likely to be truthful. But they go on to say that most employees most often don't wear PPE because they simply don't want to. That was the number one reason. According to the survey, over 70% of those surveys indicated that they don't wear it because they don't want to.
I mean, you can't argue with that.
America.
Furthermore, they said they didn't think the PPE was necessary or that it made the job more difficult.
Making the job more difficult, I can see that one.
It's tough to get around that.
Especially with like some of the gloves that they require you to wear. I don't see how
Yes.
people work with some of these gloves at all. Like the place that I just was, that we can't talk about where I was, there were people, like, they took safety, like, ultra, super duper serious. And you really kind of have to when you're there. You really don't have a choice. But, like, those guys were walking around weighted down in safety gear. And sometimes the gloves, like, I don't even know how they were fitting these hoses and pipes together that they were putting together. I didn't even know how they were gripping the wrenches and stuff to make this happen. It was mind-boggling me to even watch them work because I didn't know how they were physically articulating their fingers to grab these things and make these things work. It was crazy. But hard hats, almost everybody wears their hard hat. That's the one where, like, you've had enough stuff hit you in the head even as like a kid, as a young man, because we're all boys and we all do dumb stuff. I realized that having a daughter and her being in first grade, and we go to the playground, and like the difference between the little girls playing and the little boys playing. Oh my God, they're almost not the same thing. Like
little barbarians.
little
running around.
barbarian. Oh my God, like dude, barbarians are perfect. They were like almost tribal, and they've got all these 6 and 7-year-olds, and they all found sticks like as big as they were, and they just like automatically form a circle and start like just jamming the stick into the ground, go yeah, you know, they're running around hitting each other with sticks. I was like, what? This is crazy.
What was that book we all had to read? Lord of the Flies.
Yeah. Oh, dude. Thank God there were adults around. It would have been Lord of the Flies quick. And let me tell you, those little girls would have not had a say in anything. They were so scared. They were just like looking on in like amusement and amazement, like, whoa, what is going on over there?
It sounds like everything in my house is about to be broken because I got one of each.
Yeah, for sure. Well,
Y'all ever, when you were telling that story, it reminded me of that episode of South Park when the girls start going through puberty and it makes all the boys start acting like cavemen or whatever. Y'all remember that episode?
All the boys start going through rut.
Yeah, it was so hilarious.
well, okay, so there was a study I read recently where it was talking about creativity. So the whole idea was like, how come we as managers in the corporate world are not creative? How do we have such a hard time with creativity? And so many people who even do creative things, like, you know, we created a concrete podcast. We were one of the first ones to come up with this style, and our style was creative. It's not like any other podcast out there. But I don't know that we look at each other, at ourselves, and think that we're inherently creative. And most people kind of think that way, like, oh, I'm not creative. I'm missing this gene. It's something special. So they did like this huge, like 30, 40-year study on people, and what they found was like creativity is through the roof in kids until they get to like 6th grade. And then it just falls off a cliff, absolutely falls off a cliff. And then, like, as you become an adult, it kind of bounces back a little bit, but nowhere near levels of creativity to the point of like 6th grade. So up, 6th grade, off a cliff. And like this huge case study that they built around it, trying to analyze it about like, oh, what are the reasons for this? Is it because of social engineering? Is it because of pressures and conformity in the education system? All this stuff. And the whole time I'm like, no, they went through puberty. Yeah. And guys aren't thinking about anything except them ladies across the other side of the room. That's why the creativity went down. You want to see creativity? Watch a man try to get a girl's attention. That's creative. So, Joey, good luck to me and you when life gets to those stages with our young girls or whatever. But yeah,
that's good, man. That's good. That's a good little add-on there. I enjoyed that. We give you all kinds of things to talk about and ponder here on the Acti-Gel Concrete.
This is a concrete podcast. We don't talk college football, creativity, case studies for 40 years, longevity,
city's rat infestation issues.
Yes, sir. That I'm still mad about that.
Yeah. Well, let's bring this back on the tracks here and get to a. You want to introduce our guest here for this podcast?
Yeah, our guest today is Tiffany Duffy. She was recommended to us by Alec Yancey, and she brings an absolute world of experience from supplementary cementitious materials. And so we go way deep on fly ash, what that world's looking like right now, and where she's at in her journey, and what new products and services that they're going to be offering. The future is very bright where she's at, and we are really excited for her. But more importantly, we're excited for the audience to hear what we heard and to learn what we learned, so we all get a little smarter today.
So without any further ado, let's get into our interview here with Tiffany. Y'all enjoy.
I tell you, Tiffany, thank you so much for coming on here. Your background is actually in like different supplementary cementitious materials, right? So tell Josh and Joey here really what your background is with fly ash and slag and stuff, and then how on earth this company from Canada comes in and just, poaches you right out of the United States.
Yeah, it's, I guess, a kind of interesting story. I went to school for civil engineering, and my plan was to be in design, and I got recruited in Florida to work for a cement company in their fly ash division. And that was my first kind of foray into material sales. And it was exciting because obviously it still used my engineering background, and so I could go in and try to help optimize concrete mixes and move material. That was during the Great Recession. So, that company, Separation Technologies, had one power plant, and while I was there, acquired two more. So we basically tripled our volume at a time where, building had gone to its lowest since really the Great Depression. And it was a really, really challenging time. But, through those types of challenges comes opportunities. And I was exposed to, alternate ways to move these materials, and specifically fly ash. We had the opportunity to export hundreds of thousands of tons of fly ash to Panama for the building of a hydroelectric dam. And so it really gave me a lot of exposure into the movement of materials, the power of supplementary cementitious materials, specifically fly ash and slag, and helping to increase the performance of different concretes and properties. And so that's kind of what got me into it, and I've never really left. So I've obviously have significant experience in fly ash, but also slag and lime-based materials and cement. And really my kind of passion is trying to move into market materials that are less market ready, that have challenges from a performance perspective, or for meeting certain specs, and helping to improve those and beneficiate those and move them into the concrete industry.
So one of the big things right now is the with the fly ash shortage that there is from the closing of the coal burning power plants. People are starting to dredge the ash out of the ponds
Mm-hmm.
and dry them and then sell those. Can you uh, teach us two things here? What does that market really look like from a volume and opportunity standpoint? And then number two, is that ash like really as good as what we were using before?
So it's interesting. With the closure of traditional coal burning power plants, obviously you have a lower volume of fresh material available to go into market, and it becomes much more regional. And so the cost of that material becomes very expensive when we're talking about moving material from the Midwest, where there's still a lot of good fly ash, say up to the Northeast, where there is nothing, like in the New England region. So that makes it much more expensive. And so starting to look at reclaiming, not just from the side of finding material that's usable, but also to meet the EPA requirements to minimize ponding of fly ash. So you're not allowed to pond ash anymore. After the big TBA Kingston spill, you're not allowed to have fly ash or bottom ash in a pond in water. So those have all got to be closed, dewatered and closed. And then second to that is landfilling material into the requirement now is into lined landfills. So it's really, really expensive. So if a utility has a legacy landfill that is not lined, or is not being water monitored, or is having leachate issues, in most cases, depending on the state, those landfills are going to have to be dug up, and that material is going to have to be then transferred to a lined landfill that meets those requirements. So what leads to beneficiation is the utilities looking at the costs of doing these massive expensive projects and saying, how do we mitigate those costs? Can we pull in a marketer that's going to take that material and help fill the gap of demand for these SCMs? And so, there's cases where we see that really it's kind of a unicorn, where you find a landfill that has good quality material in there, and it's not commingled with other materials like a bottom ash or gypsum or some other type of material that would have an impact on performance. Those are very unique and few and far between. So then you look at the other ones that need closed, but they're going to need some form of treatment, whether that's processing just from classifying and sizing, drying, or separating. There's a lot of things that go into it. And to your point about, are those as good as a fresh production ash? In some cases it could be, but in other cases you're talking about material that has been sitting either in a pond or a landfill that has then interacted with water, and water with these types of materials starts to create that pozzolanic reaction. So you lose some reactivity. And that's what's interesting about carbon upcycling. They can take that waste material that has a really low reactivity rate and through their process increase reactivity and make a higher performing material. And so that's ultimately what caught my attention with the company and brought me over here.
Are you able to go any specifics about what they're doing to treat that material to make it, more reactive?
Yeah, carbon upcycling, sure. It's interesting. Carbon upcycling is a carbon tech company, so they're taking CO2 and they're utilizing that in really a two-step process to increase the reactivity and the performance of the material. So the technology is based around what they call a reactor, and within that reactor is a catalytic ball mill. So there are balls that are coated with a catalyst that help to decrease the size of the material. So intuitively, we know that finer particles can lead to a more reactive material, but this is a very unique process that also helps to what we call exfoliate the surface. So not only is it decreasing the size, making a finer material, but it's increasing the surface area. And during that process, CO2 is introduced through a stream. Does not have to be a purified stream, doesn't have to be through carbon capture. We can introduce the flue gas stream directly from a power plant or a cement kiln. And that interaction with the CO2 and the exfoliated material helps to uptake that CO2 and ultimately increase the reactivity of the material.
I have one quick question about the reactor technology, about
Mhm.
the process itself. Reactors are used for multiple different purposes and processes, and there's different types of reactors as well. But this carbon upcycling is relatively new. Has it been made possible due to advancements in reactor technology, or were you able to find something that already existed and kind of implement it into the process that you guys needed to have?
This is developed and built exclusively through our technology. So it looks like, and we're in the process of moving on to our next iteration of what we call a reactor. If you would see the current reactor at site right now, it looks like a giant ball mill. The next one is much more like a vertical ball mill, and it's kind of segregated into two streams. But this is something that was really, you could take a ball mill, but it's the internal workings that are very unique to the process. And again, it's that catalyst in there. And again, depending on the material that we would put through the system, it depends on the type of ball bearings that we would ultimately use for the processing of it. But it's everything that's going on inside. So it's reducing size, it's increasing surface area, and then through the pressurization and the CO2 introduction, that's where all the magic happens.
Well, it's interesting that you're taking these old particles and essentially, as you said, exfoliate.
Hmm.
What you're doing is you're taking what's probably oxidized surfaces
Right.
and taking that off the surface, so you've exposed a fresh surface that is now more reactive. So it's really interesting. I wouldn't have thought of that. That's
Yeah.
it's a very novel way to look at trying to make this stuff work again.
Absolutely. And what is really unique about it is, again, this is kind of plug and play at a facility. So if there is a coal burning utility that has bottom ash that they can't do anything with, we can take that material, we'll reduce the size. That's a necessary step, anyways, to get the material fine enough to use in a concrete mix. But again, to pull that CO2 stream directly from the flue gas is a significant flexibility that we have over really any other carbon tech applications out there, because we're not requiring a huge, like a high purity stream of CO2. Right now, we are on site at a natural gas facility in Calgary, and it only has 4% CO2 in that flue gas stream that we're pulling directly from. So as you increase the purity of that CO2, you get better uptake. The different materials that you introduce, you get variable in uptake of CO2. But ultimately, what you're getting at the end of the day is a much more reactive product that can offset more cement in your concrete mix. So you get a greener cement, and then you also get sequestration through that CO2 uptake as well.
I want to find out who you're trying to market this to. So quickly, the reason why I'm asking it is, as you mentioned, your interest in taking things that have not been marketed
Mhm.
or may not seem marketable yet, and trying to turn those into technologies that have value in the industry. Um, we essentially did the same thing at this company,
Right.
um, except with the change that the product that we use is not a byproduct or a waste, but rather processed further. So it's actually a specialty product. But we use it in conjunction with waste materials to make a better concrete. And you guys are kind of doing something similar just on the cementitious side
Mhm.
rather than the aggregate side. So I'd like to hear how you're marketing this, who you're going to. Just fascinated in what the plan is.
Sure. Well, let me start with the materials that we've tested. So we've tested well over 40 different types of materials. So anything from a fresh production class F fly ash, bottom ash, natural pozzolans, mine tailings, talcs, clays, a number of different products. And we're able to prove that we can create a much more reactive material through our process, and then be able to take that into either the cement production market or the concrete market. What's really interesting right now, we kind of have a moment in time where ASTM is taking a better look at what their specifications are for alternate SCMs and expanding that from a prescriptive type of model to a performance based model. And so within the next year, hopefully less than that, they will release a new spec that will relatively, that it will give us an idea on what we need to look at and how we measure the performance related to these alternate SCMs. So whether it's ash from a CFB boiler, it's microsilica, it's talc or mine tailings or aggregate fines. This will give us an opportunity to introduce that into the concrete market as an SCM and be able to test and verify that that material will meet certain performance requirements. So that's what really kind of is helping push the ball forward on our testing of materials and validating that, you know, we are able to do, again, process improvement, reactivity improvement, and ultimately CO2 uptake in these materials in a quantifiable way that you can truly measure the difference in raw material and then post-treated material from a performance and CO2 uptake perspective.
We had a discussion on the last episode of this podcast with Dr. Belkowitz, and we actually went into a long discussion about
P2P.
P2P, so prescriptive to performance based. And he was railing on that because it makes all the sense in the world, but the idea just completely fizzled out. And I'm wondering if you're seeing a different reception at ASTM looking at these performance based specs. Are they saying anything different to you that you think they really are going to allow people to move in that direction?
So from my most recent conversation with someone that's very well involved, highly involved with ASTM CO9, it is balloted right now for that performance spec for alternate SCMs and up for a vote. And then in December, there will be a meeting to either proceed with a final vote or, you know, kick it down the line a little bit further. But it really does look like there's a lot of industry support for this. And at the end of the day, it's the ready mix producers, it's the end users that are having a heck of a time finding materials that work within those kind of old school specifications or requirements. And they're dealing with finding, you know, lack of cement in the market. So we need to be able to open that up and kind of, as a sign of the times, move a little bit more forward with as the technology advances. As long as we can measure and track the performance, at the end of the day, it's the producer that's going to really take on the liability of the performance of the material. And at the end of the day, they want their material to work. So if we can measure it and test it and show that it does work in a certain application, I think that that's the way we should go. And I do believe that that's where the industry is going.
Yeah.
I'm glad to hear you say that for sure. I think for a long time, the gap between the academics of the ASTM, the ACIs, that gap between them and the producers have been fairly wide. And I think necessity is really drawing that gap closer. So it's good to hear you say that.
And I think when you sit and look at what the cement industry has been able to do with the 1Ls and the LC3s, like the different types of cements that they are developing in an effort to reduce their greenhouse gas and also extend their product, you know, you've got a nameplate capacity at a cement kiln. So if there are ways to expand that further, you know, they're open to it. And I think they work as an organization together to help drive those specifications forward. And I think finally we're seeing from an SCM perspective, the industry kind of coming together and understanding it's less about competition and more about moving the industry forward. And there's an opportunity for everyone to, to bring other materials to market with different technologies.
See, she didn't say the word collusion. So I'm not going to say
We're not talking about
that.
price.
It is interesting to me when we talk about 1L that they spent, I mean, it's been 15 years. I mean, they knew about 1L 30 years ago.
Mhm.
And then like 10 or 15 years ago, they made this like super hard push trying to get everybody to use Portland limestone cement. And then like 5 years ago, they said, screw it. We're going to make everybody use it. And then this year, they said, all right, we're all changing our plants. We're all going to 1L. Everybody at the same time, all at once, on the same year.
How's that? How's that?
Interesting.
It's amazing, right?
Yeah, amazing. But
Mhm.
he didn't say that. Just want to be clear. What she is saying, though, is that if we're going to go that far, we also need to go further. We need to look at these other options. And so if we can make this switch, we need to make other switches. What I want to step back for a second, you touched on something that is a really, really big deal in your world, which makes it a big deal in the concrete world. And I don't know that everybody's up to speed on the story. So if you know more, I'd love to hear about it. You mentioned the TVA spill in Kingston,
Mhm.
and that was huge, an absolute disaster in East Tennessee.
Mhm.
Do you think you could sort of go through that? Like, what happened there? What were the causes of that failures that have really resonated throughout this industry?
Ultimately, the TVA disaster was a result of a breach in the dam wall there of that extremely large ash pond. And when you think of fly ash, it's like ball bearings. So you get a little bit of water to it, and it's gonna flow. And so when there was the breach, and that water commingled with ash ran through for miles to destroy that area. Not only from an environmental standpoint, but from a health standpoint, there were major implications. And so that really raised the red flag on how we control these CCP residuals. What do we do with the disposal of that? And, unfortunately, there are two sides of the coin. People look at it as a product for use in concrete. What's the best way to get rid of that is to, let's put it in concrete, and then it will forever be sequestered in that material. And then there's the other side of it that looks at this is a hazardous material and it needs to be treated as such. But ultimately, at the end of the day, we need to approach it in the most viable way. And I think that's what the industry is pushing for. But, breaching the gap of billions of dollars of remediation or construction and removal of these legacy ponds and landfills, and then looking at the gap in the market, it's the technology that's going to meet in the middle and help to bridge that. And so I think that's what's driving a lot of these other specifications and industry acceptance around these materials, that we can really use it as a giant recycling program. Instead of just like burying it in the ground, let's use it to the best of its ability. And when we talk about the 1Ls and these other cements that are coming to market, a lot of people feel as if the performance of that material is less than what a traditional OPC is. And so when you have a more reactive material or a pozzolanic material that can help aid in late day strengths and improve performance of the material, why don't we look at that, and why aren't we considering that? And I think this is the time that kind of opens up those opportunities for us.
Yeah, we actually did a lot of testing. We have no connection with the cement companies. Got a lot of friends that work at cement companies. No connection, no formal connection. So we were doing some work with a ready-mix company, and we did hundreds of batches of concrete comparing just regular type 1 to 1L cements using different aggregates. And in cold weather concreting, those 1L cements really struggled to gain strength. They really struggled. And it's unfortunate because it was marketed to everyone in this rush switch, something that I don't know that anybody actually saw coming out there, that all these cement companies at the exact same time were like, nope, we're just switching everything to 1L. It was being marketed as like, hey, it's 1-to-1.
Right.
We're going to switch the cements you're not going to see any difference. We did all the testing. Well, all that testing was done at like perfect temperatures in perfect situations in the lab. And when you get out in the real world and you start, changing different ash sources, like you said, when you start changing different aggregate sources, and when you start getting different weather conditions and different things, it's not the same, and it doesn't feel the same, and it doesn't finish the same. It's
No.
different. Yeah. And so materials like yours that can make it more reactive in those cold weather environments with 1L cement, I mean,
Yeah.
you're going to see a vast improvement in the concrete characteristics.
No, I agree. And you're even missing human error when we talk about lab scale testing to real world applications. There's a major,
Human error is always implied.
I'm about to say that that goes with the regular concrete too. This podcast does not ignore human error. In fact, we have a segment at the end of the show. We're going to ask you the craziest thing you've ever seen. All right. So we focus on human error. But
Thank you for the heads up. No, the margin of error is much slimmer. So having materials that are not just going to offset a percentage of your cement in a mix to decrease cost, let's look at it differently. Let's look at a material that's going to increase the performance of your concrete mix, that's going to be able to potentially gain some green points, or get you, when we talk about the new infrastructure bill and the Buy Green initiative, I think that those are other things that we want to look at. 1L helps to fit that bill, but if we can go a step further and at the end of the day have a better product, for the community, for the end user, we have all the knowledge and capacity to do it now, and so that's what we want to look at.
So for like the past 10 years, everybody's been screaming, the sky's falling, there's no ash left,
Right.
it's all right out. Well, we've been around, and there are some parts of the country that is absolutely true. It is, fresh ash is absolutely gone. They've just went ahead and redesigned everything, straight cement. I think Joey just installed some of our part last week at a plant that did exactly that. They were just like, you know what, we're done. We're just not even going to try and get this ash anymore.
Oh yeah, they get tired of messing with it, for sure. Yeah,
exactly. So with that being the situation, this materials that you guys are working to bring to the market, what does that supply really look like? Are we talking about you're going to be able to service like a few cities like Calgary and Pittsburgh where you're at, or is this something you really think you're going to be able to get nationwide on a supply side?
I mean, obviously the goal is to go nationwide and be able to provide a solution in areas that ultimately need it the most. And so when you look at it from a marketing perspective, with any technology, there's a cost. And that's why it in our case, to be able to take a low cost or zero cost, or even a cost offset type of material that is otherwise a waste or not being utilized, and put it through the process so that it's economically viable in the market is very important. So the first steps would definitely be regional. And when I look at it from a supply demand perspective within the US, we know, in certain parts of the country, in the Midwest and sometimes down south, there is still a decent supply of ash or even slags that would help kind of fill that gap for SCMs. But when you look at New England or out west in California, where there is no legacy coal ash, there's no fresh production ash, and slag imports are starting to minimize, it's seeing where we can, have the best impact in a market that can ultimately, take on, obviously the cost of processing. And it's not a significant cost by any means, but when we're talking about, in Kentucky, where you can get, sometimes a consistent supply of ash, sometimes not, sometimes variable quality, but you're paying in the $40 or $50 ton range. If we can move out and provide a similar opportunity for materials in that same, in that same price range in an area like Boston, they could really ultimately use it. That's where we would be targeting. But at the end of the day, it's really kind of a two-phased approach. We're talking with cement producers to help utilize material, increase reactivity, either for blending at the back end or as a clinker replacement. That's one thing. And so that would have a much larger impact on a region because we're talking just volume. But there's other ways that we can go. We have a partner in Canada that we will be installing our first commercial unit, and it's right at a ready mix facility. So they're able to take an off-spec material, for very little cost, if if no cost at all, and put it through our process, and then ultimately utilize it there in their production of concrete. So there's really two steps, and it depends on how we go about it from a commercial perspective.
Well, congratulations on your first commercial success
Thank
there.
you. Thank you.
There was a time where that wasn't what your interest was. A short time ago, you decided to help a Bitcoin mining company,
Hmm.
and you're the only person I know that actually like went hardcore in the paint on that. I've got a buddy, best friend from back home, him and like other buddies that we have from high school. Like they all pulled a bunch of money together, built like these supercomputers,
Yeah.
and they're mining, but they're doing it like in their house.
Hmm.
And eventually somebody's going to get mad because their power draw in their houses are
Yeah.
insane, absolutely insane. But your company did something different where you guys actually like had a power plant
Hmm.
and were powering this kind of. Please tell the people what you were doing and your short break away from the concrete industry.
Yeah. Yeah. And I mean, quite honestly, it wasn't a complete divergence from concrete. So Stronghold Digital Mining has a business model of mining Bitcoin through their own power production, and the fuel that they utilize is refuse coal. So, Josh, you know from being from Central PA, there are mounds and mounds, like up to 2 billion tons of what they call refuse coal, but waste coal. So it's the overburden from underground coal mining activities. And that is actually the number one um, source of water contamination in Pennsylvania. So there's major issues with that. And they sit and spontaneously combust and emit all kinds of toxic gases. So um, these power plants had been built around the region called CFB boiler plants, or circulating fluidized bed plants. And so they're unique in the coal burning power industry because they can take a very low BTU value coal, or as a throwback to my West Virginia days, you can even burn a couch in there. You can burn tires. You can burn municipal waste, whatever it is,
What
just
a
to get
reference.
just to get that turbine turning. So Stronghold's model is we are going to take this waste and we're going to offset the energy demand from and the CO2 release from mining Bitcoin because of power requirements and production. And we're going to offset that by cleaning up the environment here in Pennsylvania. And so Stronghold owns 2 power plants in the state, and I joined to help get that material into a marketing condition to move into the concrete market. Really, really exciting. When I joined in about August of last year, they pushed really hard and went public at the end of October. And after hitting a few snags, and then Bitcoin goes down, they've kind of changed their model a little bit, but continuing to mine Bitcoin. And it was really very exciting, still exciting to watch what they do. I can't speak too much on the Bitcoin mining side. All I know is what you had said. It's supercomputers that pull a ton of energy. But again, the model was super unique because they were producing their own power through their own fuel source. And it had the flexibility of either sending electricity to their on-site, what they call data centers, where they're mining Bitcoin, or if the grid needed power, they could send power directly to the grid. So really, it was almost like a grid security thing as well. We talked about batteries at the earlier part of the call. This is very similar to that. I mean, it's acting as a battery. So if there was a need and a demand for electricity at the grid, we could send it directly to them. If the need wasn't there, then we can send it to the Bitcoin miners and really kind of balance out the economics of both plays.
That's awesome. And that's technology I'm sure you can scale up because they're building server farms every single day and
Hmm.
they still require a massive amount of energy.
Well, that's exactly it. Yeah.
Some of the ones they built in Texas, I
Yeah.
mean, unbelievably warehouse size
Oh, yeah. The
server.
Midwest is getting full of them.
Oh yeah. And I think that's part of the model too, is like using Bitcoin mining to fund the build out of these data centers, because it's an incredible amount of transformers and runs of electricity, wiring and security, and then being able to transition that to cloud-based AI, or these other types of high security data farms or centers. There's a ton of upside potential with that as well.
That's super exciting. That's
Mhm.
awesome.
Yeah.
Yeah, it's wild that somebody can go uh, from the power plant side of things selling into concrete and then says, oh, wait, see another opportunity. Let me use these power plants to literally power the future of currency. And then says, all right, well, let me get back into concrete too. But
I
how
feel
do
like you
you?
never get out of concrete once you're in.
Amen. Put that on a t-shirt.
Yeah.
I don't know. It almost sounded like she's trapped, like it's Stockholm syndrome.
I am. Anytime I kind of take a step out, I miss it.
It is good people. You're
Mhm.
right about that. You got
Well, I
some.
was going to ask, like, can you see into the future? How forward thinking are you? Because you went to school for civil engineering, and your first job kind of led you into this path where you are going to be in demand for quite some time because you are literally specializing in what everyone's trying to do right now in the energy sector, which is reduce carbon emissions and create new, thoughtful, innovative ways to generate energy.
Josh, I wish I could tell you that it was that deliberate, but it wasn't. But I will say, kind of once I started down the path of cement and SCMs, and then working with Stronghold as a startup, kind of understanding the ins and outs of that, you start to get exposed to other things that are coming down the line and some other advancements in technology and seeing it through a different lens. I think that in the concrete world, we kind of get stuck in the way we've always done things. And so to kind of look on from a different side of things, that there is a future in and kind of trying to marry the two, um, that's exciting. And I kind of like to keep busy and continue to kind of grow. And so with carbon upcycling, there's a lot of carbon tech companies out there, but looking at them all, this company has the opportunity to really change the entire way we look at SCMs. It's not just a raw material. It can be a manufactured SCM to a certain performance requirement, and that opens the door to so many things. And I really feel like
Yeah.
that's going to be the wave of the future.
Well, the scarcity of fly ash is what's driving that, and
Mhm.
well, not just on like volume, but pricing.
And Paul, like we've done testing with a number of steel slags that we traditionally just use GGBFS slag for applications in concrete, but there are a number of other types of slags that are produced through steelmaking process that aren't utilized. And the steel industry is trying to decarbonize as well. So it's being pushed from a number of different angles, to be able to find end uses for these otherwise waste products. And that's when technologies like this can make a huge play in that market.
Yeah, and if you can keep the cost per ton below cement, then you should be successful at the end of the day. We've seen since the time we entered the industry, 13 years ago, 12, 13 years ago now, that the price of like a Class C fly ash went from $38 a ton to $80 a ton. And then in some places, it's $110 a ton once it's delivered to the site.
Right.
And at that point, I mean, you're into the $110 a ton range, you're getting real close to the price of cement.
Right.
And that's a good point that you make. I think that from a fly ash industry perspective, we've probably not done a great job at talking about the added benefits of using a fly ash or SCM in your concrete because of the performance enhancements, and really looked at it from the old school perspective of we're offsetting our expensive powder in the mix. And I think that's another way we need to kind of look at it. And a lot of DOTs require ashes for ASR mitigation and other reasons. And but so to your point, being less than the cost of cement or even equal to the cost of cement in consideration of performance enhancement is definitely a big thing. But being able to kind of be cognizant of both things, not only cost, but also, at the end of the day, the impact on the end product is important.
Well, there has to be a real performance benefit because
Mhm.
right now the prices are getting really close to cement in some areas. And when the supply is inconsistent,
Oh,
like, so like,
you're right.
well, you're already just as expensive as the other side. I'm just going to switch. Like,
Right.
we'll figure out our pump mixes later. I'm not worried about it. But ASR mitigation, that's another story. So I'm wondering, if you guys using these 40 different materials you've tested, are you putting those through ASR test as well? Because that's the next big frontier, because as fly ash goes away, mitigating ASR becomes that much more difficult.
No, absolutely. I mean, the material that we test, the initial tests, what we're really looking for from a performance perspective through the reactor is increase in strength activity index and decrease in water demand. Those are the two primary constituents, the enhancements that we see as the material comes out of the reactor. And then as we move further down the line, it's testing that material through the whole gamut of concrete performance to make sure that we're producing a material that at the end of the day, whether it's through us or through the partnerships that we have, is going to meet the requirements and do, ultimately what we say it's going to do.
We've made it to the point in the program where it's our favorite segment, and we gave you a little bit of a forewarning here, but this doesn't have to pertain to just a concrete job site, since you've been many different places that have been unique to the traditional concrete construction workplace. But what is the craziest thing you've seen on a job site? And that can pertain to anything you do, whether it is working at CUT or mining Bitcoin and the gamut. Maybe stop a little short of your West Virginia days. And we'll keep it.
Yeah, it gets real crazy. It gets real crazy when we go back that far. Oh, geez, it was. Maybe not crazy, but I would say super interesting. When I was working in Florida, I guess when you get put into a situation, you've got to really. It always starts with working in Florida, right?
Oh my God!
Let's get a Florida man story.
This is episode 35. The majority of the people are not in Florida, and almost all the stories are like, "Well,
are you serious?"
Yeah.
This is going to be boring, though. This is not necessarily anything exciting like that. But I would say the most interesting or craziest project that I was involved in was really when we were exporting material. And, you got to fly by the seat of your pants. And when we loaded a 50,000 ton ocean going vessel by pneumatic tanker truck, and we literally just blew like 10 trucks at a time into that. I mean, it was an insane project to be a part of. Super interesting. The planning and just the logistics of it was crazy. But I mean, again, being able to pull something like that off was a pretty exciting time. I mean, there's nothing really too crazy that I've seen. I'm the fly ash person, so I always try to stay out of the mess because they're always pointing fingers. Like if there's a problem, it's the fly ash. So I don't have anything too crazy outside of that. Sorry to disappoint.
No, that's okay. We get yelled at by our logistics department on a daily basis, so
Oh, yeah.
I can understand how a project like that would be a little bit intense.
Oh, it was crazy. It was crazy.
Where were you sending that fly ash to?
That was going to Panama for a giant hydroelectric dam in the middle of the jungle. So it was just like from a logistics perspective, it was crazy. We didn't have storage at the port, so I mean it was literally taking material from the utility directly to the port. Just the train of trucks going, and like I said, just the coordination was pretty intense. But to see it all pulled off was exceptional.
How did they blow it off the ship?
They had, I think it was a Civitel unloader at the port side of things, where it was destined. So we were blowing it in, and I think they were vacuuming it out.
How much was it? How many tons?
50,000 tons in a vessel.
That is cool.
So think about 25 tons in a tanker truck. Yeah, it's crazy.
I'm thinking about the sale. Like, could you imagine being like, oh yeah, there's a 50,000 ton order. Just going down the ocean. Right
Yeah.
Done.
Yeah.
Call me
Must
next
be
year. Yeah.
Right. Call me when that commission check hits.
Yeah.
Right.
Yeah. If only.
Well, what I liked about your background was the fly ash stuff. We've done 35 episodes now. A couple repeat guests that were friends of ours. But for the most part, like every person that's come on here had like a completely different view of the industry.
Mm-hmm.
We've had QC guys on concrete, QC guys for cement, directors of cement divisions, PhD academics, industry people. I mean everything. But we've not had anybody that had like primarily fly ash background. So
from in the generality standpoint, I think that not just from fly ash, but other SCMs, the industry is changing. And I think more and more people are open to looking at alternate ways to do things, alternate materials, and how do we help to kind of improve the environment and, and decrease greenhouse gas emissions. And this is a way to do both.
but what do you mean about beneficiating? I don't know what you mean by that.
I guess like carbon upcycling would be considered beneficiating as well, but it's taking a material that is doesn't meet spec or out of quality and improving it. And from an industry perspective, you've got maybe 5 or 6 main players in the fly ash markets, and each one of them has kind of their own unique beneficiation technology. From electrostatic precipitation, which is like separation technology separator, to carbon burnout units that are basically just reburning the ash to remove the carbon, and then some other kind of indirect combustion processes to help improve the material. So there are a number of technologies out there that are trying to be employed in conjunction with reclamation and remediation projects that that are interesting and all kind of have their own pluses and minuses. And I think that carbon upcycling technology fits well into that from both an economic standpoint and ease to plug and play, and ultimately the best kind of performance improvement across the board.
Well, you mentioned all these old ash ponds are going to have to be dewatered and fixed or removed or whatever. They're going to have to be reclaimed in some way. Any idea on how many of those there are?
Oh, geez, always. I mean, I would be guessing, but there has to be.
We do a lot of guessing.
Hundreds of millions of tons, hundreds of millions, if not, upwards of nearly a billion. When you think about a traditional, if for round numbers, say a 250 megawatt power plant produces 250,000 tons of ash, and that varies depending on the coal and the ash content of the coal. But if you would use those round numbers and then look at the amount of energy that's produced by coal burning power plants or previously employed coal burning power plants, the numbers are really, really crazy. So there's so much potential to do reclamation.
Okay, so you've got all those ponds out there. And then what percentage of those would you get? Look, we do a lot of speculating on the show. We love speculating. It's like our favorite thing. So how would you guess of the hundreds of millions, potentially billions of tons of ponded ash that's out there, how many of those are going to be forced reclamation due to these regulations that are put in place?
I think that if there are cases of unlined landfills or ponded materials right now, 100% of those will have to be remediated or closed. There's no doubt about that. Dependent on where we sit with the governing body of the country, depends on what the EPA regulations are and when those are being employed. But from an industry perspective, the push is on now to do something and remediate or close those ponds. So looking at technologies and where the monies come from to do that is a whole other thing, because it's insanely expensive to either dewater and landfill that material, or reclaim it and put it in a lined landfill.
The money coming for those projects, those aren't like federal tax dollars going to that. That's having to be done privately.
It depends on the state. If the state is regulated or unregulated from an energy perspective, if the state is unregulated, then they're able to pass that through to the energy consumer. So there'll be a cost on your electricity bill to help fund that. And we see that in like the Carolinas and Virginia. In states like Ohio, those utilities don't have the ability to push that through to the ratepayer. And so then the utility takes that on. And so in a lot of cases, you're seeing either from a byproduct standpoint, like a waste disposal site, or even through emissions controls and the scrubbers that have to be put onto these plants. Sometimes the costs outweigh the performance of those plants, and that leads to retirement.
Holy smokes, that's crazy. Look, I don't want to pay for the reclamation of any of this stuff.
Right.
So don't put it on my electric bill.
Sure.
But when the government comes in and says, oh, by the way, this thing we told you could do, turns out you can't do.
Yeah.
And forces a business into doing that stuff. That gets into a whole nother like situation, right?
Oh, right. I mean, a lot of the retirements are not coming from the fact that these plants are old and outdated and aren't running anymore. It's because of the cost of meeting these environmental regulations.
Well, I think that about does it, Miss Tiffany. We're going to let you get out of here. We really appreciate you joining us, talking all things flash. We are way smarter now than we were before we walked into this room together.
Well, thank you guys so much. It was fun.
Yeah, we appreciate it.
Yep. Talk to you soon. All right, and that's going to do it for this edition of the Add 10 Gallons Concrete Podcast. We want to say thanks to Tiffany for coming on the program and enlightening us for all things fly ash and carbon upcycling related. Also threw in a little crypto mining information there, which is always good. We like to keep it diverse here on the podcast. Thanks to Acti-Gel 208 for our presenting sponsor and making this show possible. And between episodes, make sure you find us on social media. You can find us on Facebook, Instagram, YouTube, LinkedIn for some more content and also a video element to some of that content as well. So check us out, give us a 5-star rating, tell a friend about us, and see us next time here on the Add 10 Gallons Concrete Podcast.